Good morning, Algebra. Today we're going to talk about rational equations and functions. That's lesson 11-9, found on page 626 in your books. So let's get started. Rational equations are equations that contain rational expressions. As such, you can use cross products to solve the rational equations, but only when both sides of the equation are single fractions. So, what does that mean? Let's take a look. 12 over x plus 5 equals 4 over x plus 2. Okay? 12 over x plus 5 equals 4 over x plus 2. Remember that cross products are equal. So, 12 times x plus 2 equals 4 times x plus 5. 12 times x plus 2 equals 4 times x plus 5. Okay? So then I'd have 12x plus 24 equals 4x plus 20. All right, let's subtract 20, subtract 20. That leaves me with 12x plus 4 equals 4x. And let's subtract 12x, subtract 12x. So that leaves me with 4 equals negative 8x. Divide by negative 8, divide by negative 8. 4 divided by negative 8 is negative 1/2 equals x. Okay? Now, what if I have something that's a little more complex? Let's do n minus 2 divided by n minus n minus 3 over n minus 6 equals 1 over n. All right, so there's a lot going on here. So in order to simplify this, in order to get rid of this denominator, we can use the least common denominator, which in this case would be n times n minus 6. Okay, so if I multiply both sides by n times n minus 6 and times n minus 6, here I would break that out and I'd have n times n minus 6 times n minus 2 over n, okay, and then I'd have n times n minus 6 times n minus 3 over n minus 6, and this is subtraction in between, and that would equal 1 over n times n minus 6. All right. So, what can we cancel out here? We can cancel out the n with the n, top and bottom, because it's like this over 1, and so on. This is like this over 1. So then I'm left with n minus 6 times n minus 2 minus this n minus 6 will cancel with that, and so this will leave me with n times n minus 3. And then over here, this n will cancel with this, and that will just leave me with n minus 6 times 1, which is n minus 6, over 1, which is simply n minus 6. Okay? Now, if I factor this out, n times n, use FOIL, n squared, negative 6n, and then negative 2n for a total of negative 8n, and then negative 6 times negative 2 is a positive 12, minus n squared, and then you have negative n times negative 3, which would be a positive 3n equals n minus 6. Okay? Now we can combine like terms. I got n squared, and then I got minus n squared, so those will cancel out. Then I have negative 8n's and positive 3n's, which leaves me with negative 5n's plus 12 equals n minus 6. Okay, we could get rid of this 12, get rid of that 12. So then I have negative 5n equals n minus 18. And I can get rid of this n and get rid of this n. So negative 5n and a negative n would give me negative 6n equals negative 18. Divide by negative 6, divide by negative 6. That'll cancel out, leaving me with n equals negative 18 divided by negative 6 is 3. And that's it. Now, what if I wanted to find the root of a rational function? So, for instance, if I have the f of x squared minus x minus 12, x squared minus x minus 12 over x minus 2. Okay. So let's set the f of x to 0. So 0 equals x squared minus x minus 12 over x minus 2. Okay. Now, on top, I would look to break this apart. Two numbers that multiply give me negative 12. Added give me negative 1. That would be a negative 4 and 3. So I got x minus 4, x plus 3 on top. And then on the bottom I have x minus 2. And 0 equals that. Now, if x is 4 or negative 3, the numerator would become 0. So therefore the f of x would also be 0. Therefore the roots in this problem would be if x was 4 or if x was negative 3, because that would make this 0, which would equal 0. So those are called the roots. Okay? Now let's take a look at one more type of problem, and this deals with extraneous solutions. Okay? Multiplying each side of an equation by the least common denominator of two rational expressions can yield results that are not solutions to the original equation. So you got to be able to plug it back into the original equation and make sure it works out. If it doesn't, those are called extraneous solutions. Okay, so rational expressions can have both valid solutions and extraneous solutions. So let's take a look at a problem that will yield an extraneous solution so you can see what I'm talking about. 3x over x minus 1 plus 6x minus 9 over x minus 1 equals 6. All right, so our least common denominator is x minus 1. Okay, so I'm going to multiply by x minus 1, and I'm going to multiply by x minus 1. Keep both sides the same, and this way I can cancel out my denominator. Okay, so I got x minus 1 times 3x over x minus 1, and that'll cancel with that, leaving me with 3x. And same thing will happen over here. The x minus 1 will cancel with the x minus 1, leaving me with 6x minus 9 equals 6 times x minus 1 is 6x minus 6. Okay? Now I can combine things that are like terms. These guys here would give me 9x minus 9 equals 6x minus 6. Okay, and let's add 6 to both sides. So if I add 6 to both sides, then I would have 9x minus 3 equals 6x. And if I subtract 9x from both sides, minus 9x, then I have negative 3 equals negative 3x. And so then if I divide by negative 3 and divide by negative 3, I'm left with x equals negative 3 divided by negative 3 is 1. Okay, so if x equals 1, let's go back to our original equation and plug that in. If x is 1, 1 minus 1 gives me 0. And I can't have 0 in the denominator because that's undefined. So, therefore, 1 would be an extraneous solution to this equation, and therefore this equation has no solution. So, I know that was a lot to go through in this lesson. Take your time. Be sure to call in and ask questions that you have. Call, text, or email, or we can work online together between 9 and 10 o'clock tomorrow. That's it for today's lesson. Have a fantastic day.